Okay, this is one of the most common confusions or common confusion when it comes to studying diseases like Parkinson's disease or Huntington's disease. And we're going to make it simple right now. And if you're new here, my name is Lily and I'm a neurologic physical therapist. And I love to simplify the complex neuro concepts into concepts that are clear and just make everything easier than what it is. So because neuro, it's already super complex. Okay, so we're going to talk about direct and indirect pathway. Okay, so the target for the direct and indirect pathway is going to be the thalamic neurons. Okay, so how does it do that? Through the basal ganglia output nuclei. Okay, so now the direct pathway and the indirect pathway are or become concepts that show up when we're studying Parkinson's disease or Huntington's disease, right? And so let's start with the direct pathway first. Let's leave it light pink. So direct pathway. So the direct pathway is going to be the go signal. Okay, the go signal. Now, we're not going to get into the minutia of the direct pathway, indirect pathway, because we're going to get super confused. So here, I'm just here to simplify it. I love simplification of complex things. So if you want to go and research more of the specific neurons, feel free to do that. But right now, we're just going to try and simplify these two concepts, okay? So direct pathway is going to be the go signal, okay? So what happens is the direct pathway neurons are going to inhibit the inhibitory neurons. I'm going to try and draw a neuron. That doesn't look like a neuron. Inhibit the inhibitory neurons. Okay, so the overall effect is going to be excitation of the cortex. Okay, remember those like math concept, like minus and minus equals plus, plus plus equals plus, right? And then minus plus equal minus. So that is exactly what we're doing here. So you can remember. Okay, so the direct pathway neurons are going to inhibit the inhibitory neurons. Okay. Meaning there's going to be excitation of the cortex. Okay, so let me just check my notes here. Okay, yeah, so the thalamus is going to be disinhibited. Okay, so there's going to be excitation of the thalamus, and then therefore there's going to be excitation of the cortex. Okay, so a good mnemonic is direct pathway D equals D dance. So the direct pathway is going to help me dance. Okay, let's talk about the indirect pathway. And then at the end, we're going to connect it to the actual diseases, okay? What am I doing? Indirect pathway. Okay, so the indirect pathway is going to be the stop signal. Okay, stop signal. So what happens is these neurons are going to excite the inhibitory neurons. Okay, excite the inhibitory neurons. Therefore, the net effect is going to be inhibition. So think about it for a second. If you're like, there's going to be excitation of the inhibitory neurons, meaning I'm giving all the power to the inhibitory neurons. So then what's going to happen? The inhibitory neurons are going to be like, I'm ready to inhibit, right? You're giving me all the power to inhibit. So therefore, the thalamus is going to be like, all right, let's inhibit everything. There's not going to be anything. So therefore, the net effect is going to be inhibition of the cortex. Okay, so indirect pathway, the mnemonic is going to be The indirect pathway, it's going to inhibit. So I feel inhibited. I don't want to dance. Remember, the direct pathway, dance, D, direct, D, dance. Indirect pathway, I inhibit, okay? Inhibit. Now, how do we connect this to neuromuscular conditions like Parkinson's disease? Okay, so what are the things that we find with Parkinson's disease? Okay, we're going to see bradykinesia. So, what is bradykinesia? So think about it. There is decreased movement. Okay, so decreased movement. So if we're wondering, what is the pathway that is affected? Because we don't see a lot of movement. Which one is not working properly? The one that is not working properly is going to be the direct pathway. Because the direct pathway, so meaning there's an imbalance, right? There's an imbalance. We see, with Parkinson's, we see the hypokinesia, the bradykinesia, that decreased movement. So therefore, the pathway that is supposed to excite the cortex is not functioning. So what is that pathway? Is a direct pathway. Okay? Because a direct pathway is going to help me dance. Therefore, I'm not able to dance. I'm bradykinetic. I'm hypokinetic. What is going on? My direct pathway. If we put it in a seesaw, the direct pathway is not working properly. And perhaps the indirect pathway, it's too much. Maybe that's why we see this, right? The tremors. Because the indirect pathway has created that imbalance. Okay? Because the direct pathway is not working properly. Okay? So with PD, the main pathway that is affected is the direct pathway. Versus if we see with Huntington's disease, what do we see with Huntington's? What is the first thing that comes to your mind? Chorea. Athetosis. Dance-like movements, right? Hope that's how it's spelled. Okay, so what do we see? We see a lot of movement. A lot of movement. So then what pathway is not working properly? Okay, so in Huntington's, we see the indirect pathway, which is supposed to inhibit movement, is not doing its job. Therefore, there's a lot of movement that should not be there, right? So the indirect pathway, remember, it's supposed to inhibit me, but it is not inhibiting me. It is actually allowing too much excitation. So we put it on a seesaw. The indirect pathway is now at the bottom. Now, with these diseases, we care about what is not functioning, okay? So in this case, with Huntington's, the one that's not functioning properly is the indirect pathway, okay? Because again, those neurons that are with indirect, remember that we said that we are giving all the energy to the inhibitory neurons. That way we can inhibit movement. It's not happening. And so therefore, what do we see? A lot of movement, okay? So summary. And I'm going to make it a new page. This is what you need to know. Straight to the point. Like, don't confuse yourself by just reading too much about it when it comes to NCS, because then you're gonna confuse yourself. Direct pathway. It's going to inhibit the inhibitory neurons, which means net effect excitation of the cortex. Okay? Direct, D, dance. It's going to allow me to move. Remember, movement is excitation of the cortex. Okay? Indirect, there is excitation of the inhibitory neurons. Let's put here like a neuron that has like big muscles. This is the inhibitory neuron. It's giving all the power to this inhibitory neuron, meaning the net effect is inhibition. Indirect, I'm inhibited. I don't want to dance. So if we think about the diseases and a seesaw, okay, PD, what do we see? Hypokinesia, meaning there's not a lot of movement. If we think about which is the pathway, which pathway is inhibited if you mostly see bradykinesia? Which pathway is inhibited if you see bradykinesia? Well, the direct pathway is inhibited because you're seeing less movement, okay? In Huntington's disease, which pathway is inhibited? The indirect pathway, because we're seeing too much movement. I hope this makes sense. If you want to learn more about basal ganglia strokes, feel free to click on the next video so you can take a look at that. And good luck with your NCS exam. I'll see you on the next video.